Today we're going to look at operations with surds, and the learning goals for today are that by the end of this lesson we're going to be able to recall the difference between rational and irrational numbers, understand that a surd is a rational number, an irrational number that uses a radical sign. We're going to be able to simplify surds, and we're going to be able to add, subtract, multiply and divide surds. So firstly, remember that a rational number is one that can be expressed as a fraction. Irrational numbers cannot be expressed as a fraction. Some examples of irrational numbers include pi. Pi is an irrational number. You also might have seen the golden ratio is an irrational number, and surds are also irrational numbers. So they use a radical sign. We've got root 2. Now root 2 is about equal to 1.41, but it's a decimal that is non-terminating and non-repeating. So it goes on forever and it does not repeat. If I want to, so these are some other examples of irrational numbers. So we can have 5 root 11, which is 5 times the square root of 11, negative of square root of 200, or 1 plus square root 5. They're all irrational numbers, and they're all classified as surds. Surds just have a root, radical sign in there, a root. It can be a square root, cube root, any other, any nth root. So the nth root of a number, x, is written as the radical sign with the number root as n, and that's equal to y. So that's the same as y to the power of n equals x. So if I've got a square root is of 4, that's just equal to, and that's equal to 2. 2 squared is equal to 4. So they're kind of reciprocal operations. They're the inverse of each other. So it's the same with cube root. So if I've got a cube root of, say, 8, that's equal to 2. That means that 2 cubed is equal to 8. So you can do that with any root. So we'd say the cube root is also, that's the third root. You can have fourth root, fifth root, as many as you like, replacing that n value there. So when we're looking at surds, if there are a few different rules that apply to surds. If I take the square of a square root, then that just leaves the value that we had under the square root. So square root of x squared is equal to x. Similarly, if I take the square root of a value that's squared, then that is equal to x. I can also separate out the two products, or the product of two values under a square root symbol, as the product of those individual square roots, and I can do the same thing if it's a fraction. So if I've got two values that are divided by each other and then take the square root of that, that's the same as the individual square roots of each of those values over each other. When we're looking at simplifying surds, what we need to do is try and get them into this form here, separating them out into square factors. So looking at creating a product that will be the value underneath the root sign that includes some perfect squares. So remember, perfect squares are 1, 4, 9, 16, 25, 36, etc. All of the numbers, all numbers that can be that we can take the square root of easily, that are perfect squares. So 1 squared, 2 squared, 3 squared, etc. So for example, square root of 28 here, we can express that as 4 times 7, and we would choose 4 times 7 rather than 2 times 14, because we want to have a value that we can take the square root of. So that value is 4. So we've got square root of 4 times 7. Now if we use the rule up here to separate that out, we can see we get square root of 4 times square root of 7. We can work out the square root of 4, so we get 2 root 7. Now that's not, we can't simplify that any further because 7 is prime. So what we can do is we can have a look and assess whether or not we can simplify any further by having a look at whether or not there's, under the square root, as part of the surd, there's any, whether it's prime or whether there are any other square factors. So let's have a look at simplifying following values, or the following surds. So 1a here, we've got the square root of 32. Now we can have a look at trying to separate it out into its products and looking at products that will create a that are perfect squares. So 2 times 16 is the, or 16 times 2 is are the factors, and 6 are factors of 32, and 16 is a perfect square. So this becomes square root of 16 times square root of 2, and square root of 16 is 4, so we're left with 4 root 2 here. For B, we've got 3 root 200, and underneath, factors that are divisible by, or perfect squares, we've got 2 and 100, so we can go 3 times the square root of 100 times 2, which is 3 times the square root of 100 times the square root of 2, which is 3 times 10 times root 2, so we get 30 root 2 for B there. For 1C, we've got 5 root 40 over 6. So square root, or if we're looking at perfect squares of 40, we've got 4 times 10 is going to be 40 over 6. So that will be 5 times 2 root 10 over 6. We can cancel the 2 and make that 3, and we get 5 root 10 over 3. There for 1C. For 1D, we've got the square root of 75 over 9. This is the same as square root 75 over square root of 9. Now 75 can be the square root of 25 times square root of 3 over square root of 9, and we get 5 root 3, and square root of 9 is 3. So we're left with 5 root 3 over 3. And then question 2 says express 7 root 2 as a square root of a positive integer. So we're doing the reverse process. So this is equal to the square root of 49 times square root of 2, which is equal to the square root of 49 times 2, which is equal to the square root of 98. So if we look at operations on surds now, we can add and subtract like surds. It's essentially, if we can treat the value that's under the square root as that a variable, and if we've got the same variables, if I've got a plus a, that's 2a. That's the same as if I've got root 3 plus root 3, I've got 2 lots of root 3, 2 root 3. So I can add and subtract like surds. So like surds occur when we simplify, so we should always simplify first to figure out whether we have any like surds or not. So that's the first thing we should do. Simplify all surds before adding or subtracting them. That's your first step. Always simplify first. Like surds can be added and subtracted, like I've said. When we're looking at multiplying and dividing, we can, because multiplication is commutative, we can multiply in any order we like. So we can just shift them around to be able to simplify when we're multiplying or dividing, or when we're multiplying. When we're dividing, we need to make sure we simplify and keep separating out numerators and denominators, but then we can separate by as if we were multiplying two different fractions together. So if we're looking at this kind of general example here, what we've got is we're essentially moving backwards to multiplying fractions together. So when we multiply fractions together, we go, if we've got a over b times c over d, that simplifies as ac over bd. But what we've got here is we're going in the reverse process. So we're kind of separating those out into the part of the surd that is a kind of a constant. Well, they're all constants, but the part of the surd that is outside of the square root symbol, and the part of the surd that's inside the square root symbol. We can also remember to use the distributive law, where we go a times b plus a times c, which is ab plus ac, to be able to expand out brackets if necessary. So let's have a look at some of the following examples. Let's have a look at the first one, example 1a. Now we've got 4 root 6 plus 3 root 2 minus 3 root 6 plus 2 root 2. So here we've got 4 root 6's minus 3 root 6's, which is just 1 root 6. And we've got 3 root 2's, and we add another 2 root 2's, so we've got 5 root 2's here. So just sometimes it can help you if you underline the like surds in different colours, and remembering to ensure that we focus on remembering that the sign stays out the front of the value. So we've got the 4 root 6's here, and we take away the 3 root 6's. Just a very important reminder when we're simplifying like terms. So for part B here, we've got 5 root 2 minus 8, root 8. So this we need to simplify before adding or subtracting. 5 root 2. Now this can be simplified to 4 times 2. So this is going to be the same as 2 root 2. So if I do 2 squared, that's 4. 4 times 2 is 8. So I've got 5 root 2's, and I take 2 root 2's away, I get 3 root 2, if I've simplified that correctly. Then for C, we've got here 2 root 5 minus 3 root 20 plus 6 root 45. We need to make sure we simplify. So 2 root 5 is not going to be able to be simplified. We've got 3 root 20, which is going to be able to be, and I'm probably going to have to split this up because it's going to be easier for me to see. This is going to be 4 times 5 is 20, and I've got 9 times 5 here is 45, and 9 is a perfect square, so 9 times root 5 here. So simplifying this, we get 2 root 5 minus 3 times root 4, which is 6. So it's 3 times 2 is 6. 6 root 5 plus, and we get 6 times 3, which is going to be 18 root 5. And then we simplify all of this. So we've got 2 root 5's, we take away 6. That's the same as negative 4 root 5's. Negative 4 plus 18 is going to be 14 root 5 for 1C. For question 2, we're asked to simplify some multiplications and divisions. So for A, we've got 2 root 3 times 3 root 15. So we can do 2 times 3 times root 3 times root 15. Here we get 6 root 45. Now that's not simplified yet, because we can simplify square root of 45, because that's 9 times 5. So we get square root of 9 times square root of 5, which is 18 root 5 there for A. For B, we've got 12 root 18 over 3 root 3. Now we can already cancel this 3 and 12, and we get 4 over 1. Now we're cancelling because we're dividing the top and the bottom by the same number. We're dividing the top and the bottom by 3. And we've got root 3 and 18, so now we can simplify 18. So that's going to be square root of 9. Square root of 9 times square root of 2 over root 3. And so that's going to be 4 times 3, which is 12, root 2 over root 3. And lastly, question 3, we're asked to expand and simplify. So we've got 3 root 6, 2 root 10, minus 4 root 6. So we're looking at expanding and simplifying. We do the 3 root 6 times 2 root 10 minus 3 root 6 times 4 root 6. So we get, when we're simplifying this one, we're getting 6 times square root of 60 minus 12, and root 6 times root 6 is just going to be 6, because that's root 6 squared. So then we get 6, we can simplify the 6 root 60. What do we got there? 3, 9, no, 16. Maybe we can't simplify 60. So root 60, we've got 10, 30, 25, 16, 16, 15, no. What do we got? I'm not sure that we can simplify that. Oh, we can certainly do 4. Look at that, we can do 4. So 6, root 4, root 15. There we go, 4 times 15 minus 12 times 6 is 72. So we get 6 times square root of 4, which is 12, root 15, minus 72. And that's that one simplified.